Glass is a substance that we see every day. It is in our buildings, our cars, in our electronic devices, and practically everywhere around us. Its most important property is clearly, no pun intended, that it is transparent. But do we ever stop to think why this is the case? To explain, we need to answer 3 questions. Our first question is, what is glass? To make glass, silicon dioxide, or sand, is melted in a furnace with soda ash and lime. The molten mixture is then cooled rapidly in a process known as quenching. This results in the molecules arranging themselves randomly in a haphazard formation. This makes glass a special kind of solid, known as an amorphous solid. Our second question is, how do we see? Our eyes work by interpreting visible light reflected off the environment around us, entering our eyes through the pupils and striking the retina at the back of the eye. Our brains then interpret the characteristics of the light to form a picture of our environment. When visible light hits a solid object, some of the visible light can bounce or reflect off the material. The visible light reflecting off the object is what gives it its colour and makes it visible. Some of the visible light can either pass through the material or be absorbed by the material. This is what determines if it is transparent or opaque. We cannot see through a solid sheet of iron, as the visible light rays from the environment behind the sheet cannot pass through the solid metal. However, we can see through a pane of glass, as the visible light rays from the environment behind the pane can pass through the glass. Our third question is, how can visible light pass through glass? Whether visible light can pass through a substance depends on the nature of the atoms of which it is made. Each atom consists of a central nucleus containing positive and neutrally charged particles, known respectively as protons and neutrons. Tiny negatively charged particles, known as electrons, orbit the nucleus of an atom. These electrons occupy a number of shells which are at various distances from the nucleus. It is possible for electrons to jump to a higher shell further from the nucleus, but in order to do so, the electron must absorb the exact amount of energy needed for the jump, no more or no less. Light has a dual nature, meaning it is both an electromagnetic wave and a stream of infinitely tiny particles of energy called photons. In glass, the electrons in the silicon need a very large amount of energy to jump to the next shell. The energy of a photon of visible light is insufficient to allow the electron to jump to the next shell, and therefore, the photons are not absorbed by the electrons and the light passes through the substance unimpeded. And that is why you can see through glass.